We're going to do a warm-up before we start. It's very quick if you want to skip ahead. This video is time-stamped, but obviously it's going to be tougher to understand these types of skills with variables. So that's why I just wanted to go through some examples with the numbers. So I'm just going to get started. So in this foundational skills, part A, how do you divide when you have fractions involved? And that's going to be keep, change, flip. Okay, so all these skills that I'm about to go to, we're going to use all of them in the derivation of the quadratic formula. So we're going to keep that left side, change it to multiplication, and then flipping it. If that's 2 over 1, then that's going to be 1/2. How do you multiply fractions? Straight across. So 4 times 1 is 4, and then 5 times 2 is 10. So that's how it's done. If you want to just simplify fully, those are both divisible by 2. So the more simplified version would be 2/5. Okay, now in part B, what happens if you square a fraction? So you could look at it as 2 separate ways. The first one is properties of exponents. You can distribute, quote unquote, the exponent on the top and on the bottom. So that looks like 3 squared divided by 4 squared. And then just simplifying 3 squared, or 3 times 3 is 9, and 4 squared is 16. Okay, so that's how it's done. The other way you could look at it is, again, what does it even mean to square something? It means to multiply something by itself 2 times. So 3/4 squared literally means 3/4 times itself, right? And again, how do we multiply fractions? Straight across. So 3 times 3, surprise, surprise, is 9. And then 4 times 4 is 16. So we do get the same answer. So later on, we're just going to do the shortcut, which is the properties of exponents, right? We're going to distribute, quote unquote, the 2, right? Because it's being squared both on the top and the bottom. So when we do this later, I'm going to refer back to this. Okay, and then part C, we're going to be adding fractions. So adding and subtracting fractions, you must have a common denominator. So notice those do not have common denominators. So the LCD, or the least common denominator, is 8. So I can accomplish that if I multiply that second fraction by 2, right? So I'm just going to rewrite 3/8. We didn't touch it. And then again, how do you multiply fractions, right? Because this is like 2 over 2. Is multiplying straight across. So 1 times 2 is 2, and then 4 times 2 is 8. So now 1/4 is equivalent to 2/8. So now that we have common denominators, we can go ahead and combine the numerators. So 3 plus 2 is 5. And then when you add and subtract fractions, when you combine the tops, you have to leave the bottom as it is. So the final answer is 5/8. Okay, so part D is actually similar to part B in that when you have a fraction to a power, you can distribute that power top and bottom. The same goes for square rooting. So when you have a fraction inside the square root, you can, quote unquote, distribute that radical or square root symbol both on the top and the bottom. So you're just going to rewrite this, right, and doing that split of the radical. And then actually we can simplify a little more, because notice the bottom is a perfect square. The square root of 25 is 5. So the most simplified version is radical 3 over 5. Okay, the last couple of things we have to think about when we're going to be deriving the quadratic formula is, and these, by the way, are going to be exactly what we're going to do later. Okay, so I chose these problems. It's not a coincidence. So later on, we're going to see something like negative c times 4a. So is this equivalent to, in other words, is it equal to, is it the same thing as saying negative 4 times a times c? Yes, those are the same ways, because that is the commutative property. So the commutative property works for both multiplication and addition, okay? So remember that this right here is saying negative c times 4 times a, right? And this is just rearranged. That's negative 4 times a times c. So you can actually rearrange it any way you want, but we are going to, when we see this later, we're going to actually just rearrange those together. Last but not least, using the commutative property of addition, because I just said it works for multiplication and addition, what would be the equivalent expression? So the equivalent, when you use the commutative property of addition, right? You circle that plus sign, and all you do is you just swap places, if you will. So now the b squared is going to be on the left of that plus sign, and the -4 times a times c goes on the right side of the plus sign. You're technically done, but later on, we're going to actually rewrite that. Plus negative is the same thing as just saying minus, okay? So if you realize, by the way, b squared minus 4ac, that's actually part of the quadratic formula, okay? So again, later on, we're going to get something like this, and we're just going to rewrite it as b squared minus 4ac. We can accomplish that because of the commutative property of addition. So now that we have the foundation of the skills needed to derive for the quadratic formula, I'm just going to move ahead to this. Now, I do want to say, if you did forget to complete the square, I have a video that I'll link in the description on, I go over a completing the square example. And by the way, I'll also leave a link into deriving completing the square. I have that as a separate video as well. Okay, so assuming that you know how to complete the square, I will also remind you of the steps here. So what we're trying to do, the whole goal of this, right, is we want to solve for the roots. We want to solve for x of a quadratic equation. A quadratic equation just means that the highest exponent or the degree is 2, right? So we're trying to solve for x for a quadratic equation. So you can complete the square, or as I said, we're going to use the complete the square method to derive a general formula that's called the quadratic formula. So first things first, right? So to get you started, remember that the very first step of completing the square is to make sure that the leading coefficient, or that a value, is 1, okay? And just a reminder, right, when I'm referring to a, b's, and c's, a is the coefficient of the x squared, b is always the coefficient of the x, and c is always the constant. So I'm going to write and remind you the steps of completing the square on the right side. Okay, so again, step 1 is, as I said, making sure a is 1. So what happens if a is not 1? Then you just have to divide everything by whatever that a value is. So notice I got you started here already. So if I take all of this and just divide everything by a, right, that is totally legal in math as long as you do it to everybody, right? So this right here, as I said, I already got you started. That's where that comes from. So now step 2 of completing the square is always making sure that you move the term, the one without an x to it, that's called a constant. We're going to move it to the other side of the equation. Okay, so it's a little hard for people to comprehend because we're just working with all variables here. This is extremely abstract. So because it's plus c over a, whatever that general number is, the opposite of adding c over a is subtracting c over a, right? So I'm going to do that on both sides, right? So c over a minus c over a, that cancels out. That was the whole point, right? And now we're just going to rewrite that. So x squared plus b over a times x. Remember, these are just general numbers. So b divided by a, that's just, that's just the number, but we're just leaving it in general. So now when you move that constant to the other side, I like to set myself up that we're going to be adding a specific number to both sides of the equation, right? So 0 minus c over a is negative c over a, right? And again, we're going to get ready for the next step. We're about to add the same number to both sides. Now, this does not ever change the actual problem. As long as you add the same number to both sides, we're good. Okay, so now what is this mystery special number, this magic number, if you will, that we're going to be putting in the box? Well, the next step of completing the square is you're going to take the coefficient of that middle term, the coefficient of the x squared, the coefficient of the x term. So we're going to take this guy here, and we're going to cut it in half, and then we're going to take that and square it. All right, so I'll just do this work down here, and then I'll erase it, okay? So we're taking b divided by a. Remember, we're cutting it in half, in other words, dividing by 2. Surprise, surprise, this is, not coincidentally, similar to part A, okay? So remember, how do we take a fraction and divide by 2? We have to keep, change, flip. So we're going to keep the top. We're changing it to a multiplication, and this is like 2 over 1. So we're flipping it to 1/2. How do we multiply fractions? Always straight across. So b times 1 is b. And then a times 2, I can write that as 2 divided by 2a, right? So now that's what we get when we cut it in half. And then what we're going to do is take this, what we get, and we're going to square it. Surprise, surprise, that is the same thing as the second part of the warm-up, right? So remember when we were doing this warm-up problem, whenever you have a fraction squared, it's the same thing as the top squared divided by the bottom squared. Okay, so in doing that, as I said, this is the same thing as b squared, so divided by the entire bottom squared. So make sure that you put 2a in parentheses, right? We're squaring that entire bottom. So that is equal to b squared divided by, be careful, that's not 2a squared, right? Remember that this is the same thing as 2a times 2a. So this should actually be divided by 4a squared, okay? So this is that magic number that we're going to put in that box. All right, so why do I keep calling this a magic number, right? So we could add any number to both sides and it'll never change the answer, but this very specific number here, when we do this, this now is called a perfect square trinomial. So it's a trinomial, just means 3 terms. And what it means is that it can be rearranged in a perfect square form, okay? So the template for that is always going to be x plus something squared. Okay, so now what goes in this box? So remember, what goes in these first set of boxes, that was step 3, okay? So now step 4 is what is going to be in that second set of boxes. So luckily, it's connected to the first step of what we wrote in step B. So in other words, we still are looking at the coefficient of the x term, and it's going to be that first step. So whatever that is, cutting it in half. So that cut in half coefficient goes in the second box, okay? So this right here goes in the second box. So remember, the coefficient of the x term was this guy here. And remember, we already cut that in half before. When we keep change flipped it, that value was b divided by 2a. Remember that? So that goes in the second spot. All right, so we factor that, we rewrote that from standard form to a factored form. It's called a perfect square trinomial. So I'm just going to rewrite that because now it's time to simplify that right side. Okay, so we have, this is equal to negative c over a plus b squared over 4a squared. So this right side here, that's what we're looking to simplify. And that is part of the warm-up, part C. So remember, we reviewed how to add fractions. You need a common denominator. So in this case, we multiplied that second fraction by 2 because the LCD was 8. So in this particular problem, the LCD is 4a squared. So I can get the same denominators if I multiply this by 4a, right? 4a times a is 4a squared. So just remember, you have to multiply the same thing to the top and bottom. So we have negative c times 4a, right? We're simplifying that. That is the same thing, remember, so that's negative c times 4a. Here we go. That is this problem. So remember I said because of the commutative property, we're going to rewrite that as negative 4ac. Okay, so that's the same thing as negative 4ac. And then the denominator, as I said, 4a times a is 4a squared. We did not touch that second fraction, so I'm just going to rewrite that. Okay, and this is still equal to, we didn't touch that left-hand side. So now that we have common denominators, we are ready to combine the numerators. So again, I'm just going to rewrite this. We're not touching it. And this now, right, we have a common denominator of 4a squared, and we are now going to be combining the numerators. So what's negative 4ac plus b squared. Well, that is the last problem of the warm-up we did. Because of the commutative property of addition, negative 4ac plus b squared, I can rewrite that as b squared minus 4ac. So that's where that comes from. So again, this is equal to b squared minus 4ac. So we're getting there. Believe it or not, we are closer than you think. So I'm going to just update step number 4. Right? So that was step 4. And actually, I meant to draw an arrow. We want to do this, right? So that's how we got b divided by 2a, was we cut the coefficient of the x term in half. Okay, so now we are in a situation where what's our goal? Like, what are we even trying to do? We're trying to get that x all by itself. So before we do anything, we have to get that squared operation out of there. So what's the opposite of squaring? Square rooting. So just remember that when you take the square root, right, these guys cancel, you must, every time, it's always plus or minus the square root, okay? So I'm just going to update, that would have been step 5. Okay, so step 5 was, now we're using the square root method to solve for x. And I'm just going to write here, don't forget the plus or minus symbol, okay? So now on the left side, the squared goes away and we're left with x plus b divided by 2a is equal to plus or minus the square root of b squared minus 4ac, all divided by 4a squared. So now when we take the square root of both sides, right, we end up having this fraction inside the square root. What happens if we have a fraction inside the square root? How do we simplify that? Well, that is related to this warm-up part D. So when you have a fraction inside the square root, remember that you can quote-unquote distribute the square root both to the top and to the bottom. And then remember what happened here is we ended up with a perfect square in the denominator. So that's why it went from the square root of 25, and that's just 5. So the very same thing is going to happen here. So again, when we have a fraction inside the square root, we can just split that up, top and bottom. And then what ends up happening is that this bottom here, 4a squared, is a perfect square. So what times itself is 4a squared? 2a. Okay, so let me just rewrite this left side here. We didn't touch it. And now that's equal to plus or minus. Okay, so the denominator, the square root of 4a squared, is 2a, right? Because 2a times 2a is 4a squared. That top is not a perfect square, so we're going to just leave that as the square root of b squared minus 4ac. So now, believe it or not, you are closer than you think. The last step is to get x by itself, so adding b over 2a, the opposite of that is subtracting b over 2a. And actually, what I'm going to do is I am going to leave a little space here, because I think that if we write minus, right, negative b over 2a, if we write that first, it'll make a lot more sense. Okay, so again, I could have absolutely subtracted b over 2a on the right side. That's totally 100% correct. But again, I'm going to actually write that in front, right? I could do that because of the commutative property. So now we are left with x is equal to, now watch what we have here. We have a fraction adding or subtracting another fraction. Well, in adding and subtracting fractions, you must have common denominators. Look at that. Those already have the same denominators as 2a. So whenever you have adding and subtracting fractions and you have common denominators, what's left to do is to now combine the numerators. So now we have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This right here is the quadratic formula. There it is. So this formula is actually completing the square already done for you. I hope you found this video really helpful, and I want you to make sure that you check the description. I left links to also my online course if you're interested. I have chapter modules and quizzes and homeworks and step-by-step answer keys, and I have video lessons of those. So again, I left that link in the description. Make sure to like and subscribe, and make sure that you also leave a comment so that if you want to also request any future videos, I'd be more than happy to make those. So I hope to see you soon.